Hi, welcome back to Craft Crew Math. This is part 2 of the equations with two variables videos. Today we're talking about writing and graphing two variable equations. If you need help with more introductory level stuff to equations with two variables, you can click on the link above. Or if you want more advanced stuff about equations with two variables, like how to find the slope of a line, I suggest you go and visit Mr. Roper's math page. Also, click on the link above if you want more stuff like that. Okay, so let's get started with this. Tables, graphs, and equations. Tables and graphs can be used to represent equations that have two variables. The independent variable x is graphed on the horizontal axis, and the dependent variable y is graphed on the vertical axis. If you need a refresher about independent and dependent variable, watch Equations in Two Variables Introduction. Tables can help you find the ordered pairs that you need to graph. So the information here that I've written out is that independent variables are always your x, dependent variables are always your y. So that's important to figure out if you have a word problem that has both of these types of things in it. So for now, let's go over a simple example where you're given the equation and you need to graph it. So how do you graph it? Well, for myself, step one, what I would do is I would make a table to help me graph it. So step one, table. I have here x, which is my independent variable. So my table is going to be a little complicated, right? So I'm going to make my independent variable x in my table. Then I'm going to put my equation. You'll see why I'm doing all of this in just a second. And then I'm going to put my dependent variable y. And then I'm going to make another space in my table where I write the ordered pair x comma y. Now, it's the ordered pair at the end that we're really going to use to make our graph. So let's go ahead and pick some values for our equation. So I am a big proponent of not working harder if you don't have to. So when I pick my numbers, I am just going to pick some easy ones to graph. So the way that you start out all of these tables is you just choose some values for x. So like I said, I'm just going to pick some easy ones. So I'm going to do 0, and I'm going to do 1, and I'm going to do 2. So I'm just picking three numbers, 0, 1, and 2. And that's going to give me three ordered pairs that I can graph. So if x equals 0, then I plug it in to my equation, and I see what y turns out to be. So if x equals 0, then y equals 1/2 times 0 plus 3. And I know that 1/2 times 0 is 0, so that leaves me with y equaling 3, right? So when x is 0, y turns out to be 3. And then my ordered pair turns out to be 0, 3. So we're going to hold on to that ordered pair in a minute. It's going to be important. Okay, let's try for y equals 1. So when y equals 1, the equation is y equals 1/2 times 1, and then plus 3. So instead of 1 for x, instead of x, I'm plugging in 1. So now I have y equals 1/2 times 1. 1/2 times 1 is just 1/2 plus the 3. So that's going to be 3.5. So my next ordered pair is when x is 1, y is 3.5. Next, when x is 2, so y equals 1/2 times 2 plus 3. I know that 1/2 times 2 is just 1. So I wind up with y equals 1 plus 3. So then here, when x is 2, y winds up being 4. So then my ordered pair is 2, 4. All right, so I have my ordered pairs. Now, I'm going to shrink this down a little bit here so that I have room to write my graph. But all of this information is really important, so I'm going to leave it all there. I missed the one there. I'll move it back. So step one, table. Step two, I'm going to make my graph. Now, I'm going to teach you how to draw a graph here. I'm not going to go into too much detail about it because I don't want this video to be too long, but a few keys for writing a good graph. So here all of my numbers are positive, so I'm just going to use a one quadrant graph. And all of my numbers are fairly small. So on the X I have 0, 1, and 2, and on the Y I just have 3, 3.5, and 4. So I'm going to start out by making my graph. So I use grid paper for this video. Do you see this? So that I can easily draw a graph. So I'm starting out with my horizontal and vertical axis. So this is my y-axis vertically and my x-axis horizontally. Now I am going to think about the spacing of my graph. So I know that this is 0 over here, but then I need to think about what I want to count by. So for my x-axis, I'm just going to skip 2 blocks. I'm going to put the 1 there, put the 2 there, put the 3 there, put the 4 there. I'm going to let it go on like that. I don't actually get up to 3 and 4 on my x, but I'm going to show you how to deal with that in just a second. So for the y, I think I'm going to do a similar. I'm just going to count by ones as well and skip 2 grid marks as I go. So this is 1, this is 2, this is 3, and up there is going to be 4. Actually, you know what? For y, because y starts at 3, I will count by 2s. So let's do 2, 4, 6. Okay, so now let's graph it. I have 3 ordered pairs that I can put on my graph. My first one is 0 and 3. I'm going to change color so this is easier to see. So let's go with orange. So my first one is 0 and 3. So to plot an ordered pair, on the x-axis I have 0, so I don't have to go anywhere on the x-axis. And the y-axis I have 3, so I just have to go up 3. So this is my first ordered pair right here. 0, 3. For my next ordered pair, my x is 1, so I start over here at the x being 1, and my y is 3.5. So I just go up to where y would be 3.5, which would be around here, and I put my next dot for my graph. I'm going to erase this one right here, so I did put that line back. So okay. Next, when x is 2, my next ordered pair, x is 2 and y is 4. So I start out here for x being 2, and then I travel up the line to there where y is 4. So you can see here in my ordered pair plotting that I have a little line starting to form. Now I actually only need 2 dots on my graph to make a line, but I did 3. And that's fine. It makes it a little bit more precise, which is always good. So now I am going to try to carefully draw my line through these dots. And the program, the software here helps me out because it just makes it a straight line. It's nice and neat like that. And I'm going to keep going. Do you see how I'm making my line nice and long? I'm not stopping it just at this third dot here. I'm continuing it, and that's how we make a proper graph. We continue our line all the way to the end of the graph, and then we draw a little arrow on the end of it, because mathematically the graph would keep going. It would keep going forever, so I indicate that with my little arrow. But that's how you make a table and a graph from an equation. You make your table, you find your ordered pairs, then you draw your horizontal and vertical axis, you decide on your spacing for your numbers, and then you plot your ordered pairs on the graph. There you go. That's how it's done. So, equations and graphs can also be helpful for solving word problems where 2 variables are needed. So, for example, I have another word problem down here. It says a man is running a race. He has already run 250 meters. I'm going to highlight that because that's important. And he runs at a pace of 4 meters per second. I'm going to highlight that too. That's important. Write and graph an equation that represents his total distance during the race. So I have this information here about this person running a race, and it tells me I need to do two things. Number one, I need to write an equation, and number two, I need to make a graph. Okay, so for writing an equation, I'm just going to look at the problem, and this is a video about equations that have two variables, so that should be a hint for you that this word problem here has two variables in it. But I'm going to look at my word problem, and I'm going to see where the two variables are. So if he's already run 250 meters, well, then that's not a variable. That's something that I know. So I'm just going to go ahead and write down 250 meters. That's not changing. So if you're thinking in terms of coefficients and constants and all that stuff, this would be a constant because it's already been done. But then it tells me that he runs at a pace of 250 meters per second. Now, the seconds is the part that's interesting because I have no idea how many seconds he's going to run next, right? So that's a part that's a variable. So I know that he's run 250 meters, and then I know additionally every second he runs another 4 meters. So I am just going to go ahead and write 4m here to be 4 meters plus 250. Actually, I'll make that variable s to be seconds, right? Because however many seconds go by, that's however many meters she ran. So 4 times however many seconds is however many meters she runs in that number of seconds. So 4s plus 250. 250, how far he already ran. 4s, how fast he's running. So I'm combining how fast he's running plus what he already ran. And then it tells me that I'm looking for his total distance here in the problem. So that's the last variable in the problem. So I'm going to name that T for total. So total equals 4s plus 250. So the total distance that the guy runs is the speed, 4s, plus how far he already ran, 250. So that is that. There's my equation. Now, step two, I'm going to graph this thing. Okay. Now, again, I'm going to make a table and ordered pairs to do this graph. Now, this table, I'm going to do a less complicated table this time than the one I did up there. So for this table, I'm just going to put in number of seconds and the total distance. So you see somewhere in between my equation and my graph, I'm making my table to get the ordered pairs, right? So if the guy runs for 0 seconds, what is his total distance? Well, the problem tells me before I even started that the dude had already run 250 meters. So if he runs for 0 seconds, like if S is 0, then the total distance is 250. Then if he runs for 1 second, let's not do 1 second. That's not very long. So let's do 10 seconds. If he runs for 10 seconds, then that would be 10 times 4, which would be 40 plus 250. So the guy would run 290 meters in 10 seconds. And then if he runs for 20 seconds, it'd be 4 times 20 instead of 4s plus 250. So that would be 80 plus 250. So he would have run 300. He would have run 330 meters in that time. So now I have 3 ordered pairs with S and T. Now, I know up here I was doing X and Y, and down here I'm doing S and T, but you can still think of these as like X and Y, like the S is the X and the T is the Y, right? Over here the Y is the T, the S is the X. You can think of it that way, but I just use second and total for this problem here. So my order pairs would be 0 and 250, 10 and 290, and 20 and 330. Now these are really important. Those are the order pairs that I'm using to make my graph. Okay, again, so I'm going to draw my graph over here. So vertical axis and horizontal axis. Now I am just going to name these X and Y on the axes because that's just proper. That's what we name our axes. And now I'm going to think about my spacing. So down here I have the number of seconds that the guy is running. And over here I have the total meters that the guy ran. And so I need to kind of think, okay, so how am I going to do this spacing? Well, I'm going to do it similarly to what I did up here, but instead of counting by ones for the seconds, I'm going to count by tens. So that's kind of an important part of graphing, is deciding how you're going to do the spacing. You want to do good spacing so that your graph turns out to be nice and neat and not all wonky. Okay, now I'm going to do something a little funny here for the total meters. Watch this. I'm going to erase this part of the graph down here, okay? Because there's a little trick that you can do when you're working with larger numbers on one axis than you are on the other, okay? So my total distance starts out at 250, but then it actually doesn't count by that much. It counts by, it looks like 40s after that. So what I'm going to do, because I need to kind of skip all the way up to 250, is I'm going to draw this little squiggly line here on the graph. And whenever you see a squiggly line like that at the bottom of the graph, it means that numbers have been skipped. So that squiggly line is really, really helpful for me so that my graph doesn't turn out to be huge. Okay, so now I'm going to start here, and I'm going to draw my little line, and I'm just going to make this 250 right there. And then I'm just going to count by, well, over here it's going up by 40, so I'm going to count by 40. So there is going to be 290. Here is going to be 330. And up there is going to be 370. Okay, now I'm ready to actually draw my graph. So I'll get my orange pen back out and I'll start plotting my ordered pairs. So for 0, when the guy had run 0 seconds, it was 250 meters, so there. When he had run 10 seconds, it was 290 meters, so here. And when he had run 20 seconds, it was 330 meters, so here. All right, so now I have my 3 plotted points on my graph, and I'm ready to draw my line. So remember, try to draw your line nice and straight, which I get a little help because my software will just make the line straight for me. You might need to use a ruler or a straight edge of your notebook or something like that that you have lying around that has a straight edge on it to make a properly straight line for your graph. And it looks like that got a little bit off when I was graphing it, but it's good. That's okay. So there we have it. There is my equation and my graph for this guy running a race. Now, look, again, I drew the arrow to say that this guy keeps running, right? The guy is still running. Here he is. He's running. Woo! But he doesn't stop at just 330 meters. That would not be a very long race, right? Like he keeps going and runs for 30 seconds and 40 seconds and a minute and maybe an hour, right? Like this guy keeps running on this race until the finish line is reached, which the problem doesn't tell us when the finish line is. So we just represent that with an arrow so that he just keeps on going. Okay, so we did a sort of simple level problem, and then we did a word problem where we did an equation and a graph, and now we are going to look at a rate problem. So I have a little note here. It says MIDI rate problems can be modeled using the distance formula, which is this here, distance equals rate times time. That's what D equals RT stands for. D is distance, R is rate, and T is time. Where D is the distance, R is the speed, and T is the time. So for the distance formula, it tells me that distance is equal to rate times time. Now, if you're looking at that, that's actually really, really helpful because that's already an equation set up for me. I don't have to do any extra work because it's already there. So if I get a problem like this little example that I have right here, where there's some distance and there's some rate and there's some time, then I can be thinking about the distance formula, and that can help me to go ahead and write my equation. So here it says a car travels 80 kilometers per hour between two cities. Write and graph an equation to show the relationship between time and distance traveled. How long does it take the car to travel 220 kilometers? I'm going to change back to my purple color. So, if the car is traveling 80 kilometers per hour, and I'm thinking about the distance formula, 80 kilometers per hour, that's going to be my rate. See here, R, rate. And if it tells me that the car travels 220 kilometers, well, then that is going to be my distance, isn't it? Okay, but at first, what the problem tells me to do is to write an equation, write and graph an equation to show the relationship between the time and the distance. So the relationship with the time and between the time and the distance is going to be modeled by the distance formula. So step one, I'm going to use the distance formula to actually write out this equation. So if it's distance equals rate times time, and my rate is 80 kilometers per hour, then my formula here, or my equation, is going to be d for distance equals 80, because that's the rate it gave me, times the time. So d equals 80t. Later in the problem, it tells me that the actual distance traveled is 220 kilometers, but it doesn't tell me that at first. And it tells me that I need to make a graph for this equation, which if I am going to make a graph, then I need an equation that has two variables in it, not one variable, okay? So I'm going to hold off on plugging in that 220 kilometers. If you're thinking to yourself, why didn't you put that in for distance? Hold on, we're going to do that in a minute, okay? But first, I'm making an equation that has two variables in it so that I can make a graph. Okay, now to make my graph, so part two here, I'm going to make my table. So this is my table. Again, I'm going to do a more simple table than what I did in the first example. So here, we're going to do time. Let's just make this be in hours, since we had kilometers per hour up there. And then we're going to have distance on the table, and that's going to be in kilometers. So here's my table. So again, I'm going to choose simple numbers. So 0, 1, and 2. Those are the numbers I'm going to pick for the time. So 0 hours, 1 hour, and 2 hours. So if the car has traveled for 0 hours, then it has gone to 0 kilometers, because distance would equal 80 times 0, which that would just be 0. But then if the car has traveled for 1 hour, that would be distance equals 80 times 1. And so then the distance would be 80. If the car goes for 1 hour at 80 kilometers per hour. I think I'm switching up kilometers and miles a bit in this video because I'm an American, and usually I think in terms of miles per hour, but I'm trying to make this video a little bit more internationally friendly. So I'm trying to use kilometers. So pardon my Americanness if I say miles per hour sometimes. Anyway, so then for 2 hours, how far does the car drive? So if the distance is going to be equal to my speed, 80, times 2 for the number of hours, and that's going to give me 160 kilometers that the car has traveled in 2 hours. So now I use the formula, I use the equation to come up with my time and my distance. Oh, I just noticed that I spelled distance wrong down here. That's embarrassing. Let's go ahead and erase that little s there. Boop. Just move that over. And this gives me my ordered pair. So my first ordered pair here is going to be 0, 0. My next ordered pair was 180. My next ordered pair was 262 and 160. So those are going to be what I use to make my graph. I'm going to shrink this stuff down a little bit so you can still see the problem up there. And I'm going to draw the graph over here. So part 3 is the graph. Now again, like I did for the other graphs, I'm going to draw my vertical and my horizontal axis. I'm trying to do the best that I can to use these grid lines to help me to draw this graph neatly, but bear with me if it's a little off. So this is my y-axis and my x-axis, and this is my time down here in hours, and this is my distance over here in kilometers. Okay, so now I have to think about the spacing. The spacing for time is easy. I'm just going to count by ones again. So this time I'm going to skip 3 blocks though. So this is going to be 1, 2, 3 over here for time. And then distance, I think I'll count by, let's count by 50s. So I'll skip 2 blocks and put 50, 100, 150, 200 at the top. Now I just need to put on my ordered pairs that I made. So my first one was 0, 0. Well, that's easy, isn't it? It just starts down there, the origin. That little bit there is called the origin. And then the next one is 1 and 80. I have to do a little bit of thinking about where this one goes because I didn't count by 80s on the vertical axis. So look, so I'm going to go over to my 1. I'm going to go up. In the middle between 50 and 100 there will be 75. So I'm just going to go up a little bit from that. I'm going to put it there. Okay, that'll be 80. The next one was 2 and 160. So I'll go over to my 2 and go up to about where 160 would be, which would be just above the 150 there. So then I can do my line. And then boom, there it is. Look, we'll do this about as precisely as we can. There. And so there is my graph for that. Okay, so I did my equation here. I did my graph over here. And now I need to go on to the next part, which is the problem says, the final part of the problem says, how long does it take the car to travel 220 kilometers? Well, if I know that the car is going at 80 kilometers per hour, and I already have this equation where distance is equal to 80 times the time, and it tells me that the distance is 220. Well, now I can just use the equation to figure out the missing time component. So it will be 220 equals 80 t. Okay, well now I just have a simple one variable equation to solve, right? So I have 80 times t equals 220. So if I just use my inverse operations and I divide by 80 and I divide by 80 on both sides, the 80s go away there and I have t equals 220 divided by 80 turns out to be 2.75. So I found out that after I divided that the time is 2.75 hours. So it takes 2.75 hours for the car to travel 220 kilometers. There you go. That's the end. All right, you guys, thanks for watching this video. If you need more help, go and see the part 1 of the introduction to equations with two variables. Otherwise, I will see you next time for more math.